So this was a short question that was in the attention quiz section of the lecture for 15.2 to 15.3. So hopefully you worked that through on your own, and this is just a short video that goes through the solution. So here we have a bullet of mass 0.02 kilograms, and it's traveling at a velocity of 1,200 meters per second to the right towards this block of mass 0.3 kilograms. And if the bullet becomes embedded in the block, we need to figure out what the final velocity then of this block and bullet combined are. So this is an example of an impact problem where we have a plastic impact where we don't have separation. We just have a collision where they stick together. So we can use the conservation of linear momentum along the line of impact, okay? And so then we can solve for the final velocity of the two combined. Okay, so what we're going to do is we're going to label the bullet particle 1 and the block particle 2, just for our little notation here in our conservation of momentum equation. So our conservation of momentum, we have the initial momentum for the bullet plus the initial momentum for the block. And now that they become embedded, so the bullet becomes embedded in the block, we can add up the two masses. They become one system. And we have one velocity then, that's a common velocity. So we only have one equation with one unknown. If we plug in our values, we have our mass of the bullet, 0.02, times the initial velocity, and it's going in the positive x, so it's positive 1,200. The block is at rest, so there's no momentum there initially. And then our final momentum, we add up the masses, and we're going to assume that our velocity is also going to the right, which is a positive x direction. So we'll let our math tell us if we're right or wrong. And when you solve this, you get the final velocity is 75 meters per second. So it is positive, therefore the direction is going to the right. So hopefully you got that answer, and if you didn't before you saw this video, this makes sense now. So hopefully you will be able to solve these equations of conservation of linear momentum, and you understand the difference between the impact problems when a particle embeds in another and becomes coupled and it acts as one unit, versus those impact problems where they break apart and now you have a restitution that you have to deal with and you have two equations with two unknowns.